Hey guys, welcome back to another video, and today I'm going to be talking about the properties of exponents. So first of all, I wanted to define what is an exponent. So it's usually in this form, where a is the base and n is the exponent. So an exponent is basically repeated multiplication of the base. So if we have the base, which is 2, which is always a big number, and we have raised to the 2 power, that means you get this number, the base, you put it here, and you times it by itself 2 times. So 2 squared is 4. If we had 2 to the 1, it's just going to be 2, because we times it by itself 1, so it's just going to be 2. That's all. That's an identity actually. So to start the video off, because I just defined what exponent is, anything raised to the 1 power is itself, and anything raised to the 0 power is 1. So if, for example, we have 2 raised to the 1, that's going to be 2. But if we have 2 raised to the 0, that's going to be 1. So anything raised to the 0 is always 1. So if we have 5 raised to the 0, 25 raised to the 0, 6 raised to the 0, these are all equal to 1. But if we have something 6 to the 1, that's going to equal 6. And if the number doesn't have an exponent, like this, it's always raised to the 1, right? So they're just going to assume that you know it. So one of the most important properties is the product of powers. Product of powers. So if you have a of m times ace of n becomes ace of m plus n, right? So what does this mean exactly? So if we have two exponents, okay, with the same base, we have 2 squared times 2 cubed, they have to be the same base. All these properties have to have the same base. Well, most of them. But the product of powers states when you have two exponents with the same base, you can add the exponent. So 2 squared plus, so it would be 2 plus 3. It's all you do. So it would be 2 to the 5. And this is applied when you're multiplying exponents. When you're multiplying exponents with the same base, that will give you you add the exponent. So if we have, for example, x to the x cubed times x to the 5th, this is equal to x to the 8. And if we have y to the 1 times y to the 7, this would be y to the 8. Because there's the same base, we just add the exponents. Okay, cool. So if now we have the second second property of exponent, which is the quotient of powers. So now we have the same base, but we're going to subtract the exponent. So if we have ace of m divided by ace of n, this is going to equal to ace of m minus n. And a cannot equal 0, because if we make a equal to 0, we get 0 to the 2 divided by 0 to the 1. This would be equal to 0 to the 1, and we can have a 0 in the denominator. So just remember that your bases cannot equal 0. Okay? And so yeah, so if we have, for example, x to the 9 divided by x to the 2, what would this be? Since they're the same base and we're dividing, we just subtract. So 9 minus 2, it would be x to the 7. Okay, let's try this one. If we have s to the 10 divided by s to the 3, what would this be? Since there's a property, we just subtract the exponents, so it would be s to the 7. Cool. So that's the quotient of powers property. So now we have the third property, which is power of a power. So if we have an exponent raised to a power, this is equal to AMN. So we just times these two numbers together. So if you have an exponent raised to a power, we just times it. So for example, if we have x squared raised to the 4, you just times the 2 and 4 together. So it's going to equal x to the 8. Okay? So for example, if we have y cubed to the 5th power raised to the 5th power, y cubed raised to the 5th power, this would equal to y to the 15. Now why is that? It's because when you have a quantity like y cubed raised to its individual power, you can write that 5 times and we'd apply the product property rule. So if we took this answer right here and we wrote it as y cubed times, it has an exponent now to the 5th, right? And you write it 5 times as so. We just add the exponents, so it would be 3, 6, 9, 12, 15. So we get the same answer, right? So, but the other way is easier. So if we have x to the 3rd raised to the 2nd, this will just equal x to the 6th, because you just times the numbers together. Okay, cool. So now we have a power of a product. Okay, it's the same thing as the other rule, the power of a power, but this one states that if you have a times b raised to the n, it's equal to a to the n times b to the n. So it's almost the same. It's almost the same as the second one, except here we don't have powers. I mean, we could have powers you could apply, but for example, if we have like 2x raised to the cubed, we'd write this as 2 cubed times x cubed. So what would this be? This would be ax cubed, right? So if we have, for example, 3ab raised to the 2nd power, we can just times each number by raised to its power. So it would be 3 squared times a squared times b squared. So it would be 9a squared b squared. Or we can just write this out, 3ab times 3ab. So this would be 9, 1, 1, 1, 1. And we get 9a squared b squared. Same answer. So, yeah. So now we have a power of a quotient. So if we have, power of a product. Now we have product of a quotient. So if we have a divided by b raised to the n power, we can write this as a to the n divided by b to the n, and b cannot equal 0 because you can't divide by 0, right? So for example, if we have 2x to the 3 divided by 3, 2x divided by 3 raised to the 2nd power, we can write this as 2x squared divided by 3 squared, and like this. So then we get 4x squared all over 9. See, I applied the power of product rule from before on this one. So for example, if we have 5y divided by 2 raised to the cube to the 3rd power, we write this as 5y cubed, 5y to the 3rd power divided by z to the cube power. So make sure you do in parentheses. So that would be 5 to the 3rd is 125. 125 y cubed divided by 8. Okay, and I also mentioned the 0 exponent, so anything raised to the 0 is 1. The base cannot equal 0 because 0 to the 0 isn't correct. It doesn't even equal this. So just ignore this. Just remember that. So if we have 7 raised to 0, it's going to equal 1. If we have x raised to 0, so anything raised to the 0 power is always 1. And then we have negative exponents. So if we have a raised to negative n, this is the same as 1 over a to the n. So if we have, so you get this number, you write 1 over that reciprocal. So if we have x raised to negative 4, this is the same as equal to 1 over x to the 4th. So if we have y to the negative 2, this is the same as 1 over y to the 2. Okay, and this is the negative exponent rule. So now we have the fractional exponents. So in the square root, we have what's inside the radicand. So we have the base, and we have its power, and we have the index of the square root. So this is the same as a to m divided by n. Why is that? Because, for example, there's a property. So if you have some sort of root, right? Like if you have the square root of 2, this is the same as x to the 1/2. So when you have a square root or a cube root or something, you can just write it as x raised to the 1 over what kind of root that is. So if you have the 4th root of x, it would be x to the always 1 divided by 4. So that's also an identity. So if we have x to the m raised to the n, this is always x to the m divided by n. So it turns out for a regular square root of x, right, the reason that it's 1 over 2 is because it's just 1. The power is 1. So if we have, if they gave us something like this, so x cubed to the 4, we can just write this as x to the 3 over 4. Okay, now why is that? It's because if we write this as x, the square root of x, in the cube 4th root of x, which is x to the 1/4, right? And then we raise it to the 3rd power. We can apply the property. We get x to the 3 over 4. So that's a trick you can use. So the identity is, so if you have x to the m over n, this is the same as x to the m over n. So if we have x to the 1/2, okay, this is the same as x to the 1 over 2. Okay, so if we have x to the 2 over 3, this is the same as x2 raised to the 3. So if we have y to the 3 over 2, this is the same as y3 to the 2. If we have x to the 5 over 3, remember this is m. We look back, m, and this is n. So we just get the top number, we just write as x to the 5, and this 3 would be some sort of root. Same thing here, we'd write this as x to the 5 over 3, and there. This is something that confuses a lot of people, but it's just really memorization. You don't know what to do. Okay, so yeah, that's really it when it comes to exponents. So now we're going to try some examples, right? So for example, if we have 2x squared times 2m to the cubed, or sorry, x, 2x, we can apply the product of property rules, which states that a sub m times a sub n is equal to a sub m plus n. So let's apply that. So it's going to be x cubed times x to the 3rd, it's going to equal to x to the 5th, and then we're going to do 2 times 2, and we're going to get 4x to the 5th. Alright, so cool. Now let's try another one. Let's try x to the 4 times 2x to the negative third power. So what can we do here? Can we apply the product of property rules? Let's think about it. Can we? Well, first what I want to do is I want to use the negative exponent rule, which states that x to the negative 3 isn't equal to 1 over x to the 3. So I'm going to do x to the 4 times 2, I'm going to leave this in the parentheses, 1 over x. What's wrong with this? 3. And since this is 2 over 1, it's just going to be x to the 4 times 2 to the x over 3. Oh, my pencil is tweaking. So then we're going to get 2x to the 4 divided by x to the cubed. And what we're going to get, realize that we can use this is 1 times x cubed because it's the same thing. And then realize that we can use the quotient property rule. So it says that x to the m divided by x to the n is equal x m minus n. So we're going to get 4 minus 3. So we're going to get x. So it's going to be 2x. That's your final answer. Okay? Let's try another one. So if we have 4r to the negative 3 times 2r squared. First of all, I'm going to apply the property. So it's going to be 4 times 4. I'm going to leave it out for now. 4r cubed. 1 over r cubed times 2r squared. Now I'm going to times it. 4 times 1 is going to be 4 divided by r cubed times 2r squared over 1. And now we're going to get 8r squared all over r cubed. So 8 divided by 1 here is going to stay. So I know I'm going to have an 8 on the top. And then 2 minus 3 is what we're going to get. We're going to get a negative 1. So r to negative 1 on the top. Because when we subtract, the bottom is always going to go away with that property. So it's always going to be the top. So we have 8r to the negative 1. So then r to the negative 1 can be written, let's just leave it out for now, as 1 to the r to the 1 power. And we can distribute that 8 or times it, like times across. So we get 8 to the r to the 1 power, which is the same as 8 to the r. Cool. So let's try another one too. If we have 4n to the 4, or no, and let's try 4x to the 4 times 2x to the negative 3. How would we do this? So first of all, I'm going to again rewrite the negative exponent as its reciprocal. So 4x to the 4 times 2 times 1 over x cubed. Okay, so now I'm going to get 4x to the 4 times 2 divided by x cubed. And I'm going to multiply across. And I'm going to get 8x to the 4 divided by x cubed. And I'm going to divide, and I'm going to get 8x. That's your answer. Cool. So now let's try another one. So let's try this one. So 2x to the third, y to the negative 3 times 2x, negative 3, times 2x to the negative 1, y cubed. Now this looks crazy, but it's really simple. So this is a term, and this is a term, and each individual term we can't combine because there's different exponents. So, and since they're being times, each term being times each other, I'm going to split it up. I'm going to do the x's by themselves. I'm going to do the y's by themselves. So I'm going to write it as 2x cubed times 2x to the negative 1. And I'm going to write it as y to the negative 3 times y to the third. Now I'm going to do each one separately, and I'm going to add our results. So 2x to the third times 2x to the negative 1. I'm going to apply the product of properties rules, product of powers. So it's going to be, just leave it out for now, 2x to the third times 2, 1 over x. So I'm going to get 2x cubed over 1 times 2 over x. So now I'm going to get 4x to the cube divided by x, and this is going to give me 4x squared for the x's part. And then for the y part, we're going to do is we're going to write it as 1 over y cubed times y cubed over 1, and we're going to get y cubed divided by y cubed, which is going to be equal 1. So if we do 4x squared times 1, we're just going to get 4x squared. And that's our final answer. It says everything is multiplied by each other. We're just to multiply everything by each other, we're going to get that answer. So if we had this one, for a cubed times, or well, b squared times 3a to the negative 4, b to the negative 3. Let's go ahead and do the same thing as before. So do the a's and then do the b's. So it's going to be 4a cubed times 3a to the negative 4, which we can rewrite as 4a cubed times 3 factored out a to the 4. Okay, and now we're going to do some multiplication. So we're going to get 4a cubed over 1 times 3a to the 4, and we're going to get 12a cubed divided by a to the 4, and then we're going to get 12a to the negative 1, and then we're going to do 1 over a to the 1 power, and we're going to get 12 over a. Okay, and now the b part, we're going to do b squared times b to the negative 3, and we're going to write this as b squared times 1 over b to the cubed, and we're going to get b squared divided by b to the third, and we're going to get b to the negative 1. Now if we combine the two, we do 12a divided by 1 over b, we get 12 divided by ab, and that's our final answer. Wow, cool. So you can see how it takes some work, but not that difficult. So we did product of property, we did the reciprocal rules. Let's do a product of a product of a power. So we have 2x, let's zoom in. So if we do 2x squared raised to the negative 4. Okay, we can write this as 2 to the negative 4 times x squared to the negative 4, right? So this is just a power of a power. We convert this to a, well, it's a normal power, or the negative, like a exponent, and this convert to a power of a power. So now we're going to do 2 to the negative 4, which is 1 over 2 to the 4 times x to the negative 8. So we can write this as 1 over 2 to the 4 times 1 over x to the 8. 2 to the 4 ends up being 16, so we're going to do 1 over 16x8 because we're timing them. And that's our final answer for that one. Cool. Okay, so that's basically it. I'll make a different video on more examples, because there are some that require multiple steps and different, as you can see, combinations of the few. I did a few basic, I did a few combining, but if you know your rules well, you'll be fine. The most important one is the products and the quotient rules. So hopefully this helped, and have a great day.